Hey guys, it's Ms. Brown's class. So today we're going over what the difference is between theoretical probability and experimental probability. So as you can see, theoretical probability is what we expect to happen, and experimental probability is what actually winds up happening. So if we were flipping a coin, about 50% of the time we expect it to be heads, and 50% of the time we expect it to be tails. In reality, that isn't always the case. It could wind up being like 48% of the time it's heads and 52% of the time it's tails. So we're going to do a couple experiments and see what actually happens. All right, so I have a deck of cards here, and there are 4 suits or shapes. So we could wind up getting hearts, diamonds, clubs, or spades. We expect the frequency to be 1/4 of the time for each of those shapes. So if I have 4 cards that I turn over, I expect there to be 1 of each shape, right? So let's see what I get. A diamond, a spade, a club, and a diamond. So what we expected was 1 of each shape, and what we got in reality was 2 diamonds. So in reality, our probability did not match our theoretical probability, because our theoretical probability would have been 25% for each of these shapes, plus also 25% for heart, but really we got 50% for the diamonds, okay? So this is an example where it does not match perfectly, okay? Just like we were talking about with flipping a coin, it does happen where it doesn't always match up 50% of the time, okay? Also with cards, we could do an example where there's 13 different numbers or values that you can get for cards. You can get ace through 10, which are like 1 through 10, plus jack, queen, and king. So that's 13 different values. So if I took out 13 different cards, you would expect to get 1 of each of those 13 cards. So let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So looking at these cards, you can see I didn't get that perfect the perfect theoretical probability. You can see I get repeat values here of 10s, and also I repeat the value of jack, and I repeat the value of 5. So our experimental probability does not match our theoretical probability. When you're going to be doing assignments this week in Canvas, you're going to have to pay attention very carefully to see if the questions are asking about what the experimental probability is versus what the theoretical probability is, because those two change very, very much. Prior to spring break and all this mess happening, we had taken a test on experimental probability. Your experimental probability was all about reading the chart and seeing what actually happened. So when you had done that, you would have said 3 out of 13 times you had gotten 10 as a value. So you would have said the experimental value is 3/13 of the time you will get a 10. All right, so enough playing with cards. Said no one ever. Okay, you'll also have problems where it's asking you to roll a dice or a die. Grammar is not my forte. Okay, there are 6 sides on it. Okay, we know this, it is a cube. Okay, if it's only rolling 1 at a time, it should be a 1 out of 6 chance. Okay, if I roll it 6 times, you would expect that I'd get 1 of each value. Is that guaranteed to happen? No. You must understand theoretical value is not a guarantee. It is just what we think would happen. Now, the more times I do an experiment, the more times it'll average out and be closer to that 1 out of 6 times it'll land on each value, okay? But if I only do it 6 times, chances are I won't get 1-1, 1-2, 1-3, 1-4, and so on. Whereas if I do it 600 times, chances are it'll be closer to about 100 of each value, maybe like 102 and 98 and closer values. Now, there are other weirder scenarios that your Canvas assignments will ask you about. It'll ask you about spinners, okay? I believe we did a problem in our textbook about a spinner with twister. Okay, here you can see that there's 16 different spots where it could land, okay? There's 4 different body parts, and each body part has 4 different colors that you could land on. Okay, right now this is on a flat surface ping pong table. Yes, that's my kitchen table, don't judge me. Okay, so if I spin the spinner, theoretically it should be able to land anywhere, right? Okay, hopefully it's not always in the same spot. Okay, see how it lands in opposite corners? Yay. However, if you saw that it was always landing in one area, you may have to think, is this being tilted in some way that's causing it to land a certain way? Or is there something on the bottom that it's getting caught on? Is the surface sticky? Okay, you would have to think, is there anything that could possibly be going on? Okay, so when we're looking at probability and statistics, there are a lot of questions you have to think to yourself, and you kind of have an inner dialogue, okay? So there are actually a couple of discussion questions that I opened up on Canvas. So I want you to really think to yourself on some of these questions if you are always getting the same answer. So if you're rolling a dice or a die, why might it always be rolling and landing on a 1? Okay, is there something wrong with it? Are you not rolling it properly? Are you rolling like this and really like not turning your hand much? Do you need to be dropping it from a higher height? What's going wrong in a situation? Okay, I have these cards, but I also have a larger amount of cards here. Okay, is my deck faulty? Okay, did I scam somebody? Because you guys know maybe Miss Brown likes to rig the system. Okay, so what is going on here? You have to constantly be questioning what's going on with the statistics. Okay, so look for that in your discussion questions. If you have any other questions, email me and I will be happy to help you.